Welcome to another Intermediate Algebra video. In this video, we'll look at a few different methods for solving two linear equations. So our objectives. The first one is kind of an introduction into really the other two objectives. First, determine whether an ordered pair is a solution of a system of two linear equations. And then also solving a system of linear equations using three methods: graphing, which we'll just touch on a tiny bit, and then using substitution and elimination. So these two, substitution, elimination, they are the meat and potatoes of this section. They're the majority of what we're going to discuss throughout. All right. So let's talk about the possibilities that we have here. So we're talking about two linear equations, linear meaning line. So what are the possible ways that these two lines could interact? Let's say we have three different possibilities, three different things that could happen. It could be the case, let's draw these in red, pretty easily, that the two intersect at one location. They might be, perpendicular like this. It might be that they just cross a tiny bit and keep going, but this is one thing that could happen. It could be that you get one solution. Okay, what else could happen? What else could two lines on the same plane, how could they interact? Another possibility is that the two lines are parallel, and if that's the case, then you'll have no solution. We're looking for where they intersect. So it could be that they're parallel, in which case we have no solution, and it could be that, and I'm drawing a different direction, but it doesn't have to be. It could be that they are essentially the same line. In which case, there are infinitely many solutions. And I'll show you how to notate each of these when we come across them. But I want you to keep this in mind when we're solving any of these problems, so that you know if something odd happens, it could be that it's not the unique case of one solution. It could be that there's no solution, one of the special cases. It could be that there's infinitely many solutions. So keep that in mind. All of these we're solving how these two lines interact with each other. Okay, so let's first look at solving by graphing. If you have your calculator, you can take a look at that. We're going to use the intersect option on the calculator. I'll explain how to get there. So these are the two equations we have: x plus y equals 2 and 3x minus y equals negative 2. So these two will interact in a way we're not exactly sure. We can put them on the calculator and check, but the long-term goal isn't to always do it on the calculator. In order to type them into the calculator, what do they need to look like? Remember, they need to say y equals everything else. So if we solve the first equation for y, we'll have y equals negative x plus 2 or 2 minus x. Either one's fine. And then the second problem takes a little bit of work. Subtract 3x from each side. And then divide everything by negative 1. We get y equals 3x plus 2. So go to your y equals screen on the calculator and type each of these in: negative x plus 2 and 3x plus 2. Then go to your graph. You can see these two lines interacting with each other. You can see, I'll give you the general sketch if you're not typing it along on your calculator. Something like this and something like this. And you might be able to kind of scroll around and guess what you think the intersection would be, but there's only one foolproof way to do it on the calculator. And it's to go into the calculate menu. So you'll hit second and then the trace button, which will take you into the calculate menu. Then you'll scroll down to intersect, should be about the 5th option down, and hit enter. And it's going to ask you first to hit a point on the first line. You can scroll back and forth on the line, but you don't have to. You can just hit enter. It asks for something on the second line. You can hit enter. And then it says guess. You can hit enter. This type of thing would be important. Well, after you've hit enter the third time, it'll give you that ordered pair somewhere on the bottom of the screen. And that is it. That's your answer. Looks like, what do we have? About 0, 2. 0, 2, and 0, 2. Good. 0, 2. And in this case, you would be correct with your guess from the graph itself, but the only foolproof way is to go through those steps on the calculator. It lose me. What else I was going to say? The reason that it has you put enter, 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 something on the first line, second line, and third line. Right now, we're looking at 2 lines, so there's only one place that they'll intersect. Let's say, for example, and this is long term, you have a graph that looks something like this, and then there's a line going through it. Well, in this case, there are quite a few different intersections. So the calculator is asking you to basically narrow it down. Which one are you talking about? This isn't something you're going to see in this class, just to give you an idea why it's asking that. So those steps in the calculator, again, are to get into the calculate menu. So you hit second trace, then down to intersect, and then you can hit enter, 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 and it'll give you the answer. It'll give you that ordered pair. If you see something like a number, this is an example, 5.2 times e blah, blah, blah. This essentially means 0. This is calculator error. It's not exactly finding the point where they intersect. It's finding a place they intersect that's a tiny, tiny, tiny bit off, but just assume that it means 0 if it gives you a number like that. It's saying 5.2 times 10 to the whatever number comes after here, 16th, which means it's 0.000016 of them. Just assume it's 0. So while the calculator can be helpful, there are a lot of, pitfalls to using it. It can give you the answer, but you've got to be able to interpret everything it's saying correctly. So this is one way, and we're just touching on this very briefly. Okay, so go ahead and practice really quick typing these in the calculator and seeing what you get for the intersection. Remember, you need to have solved for y before you type any of them in. These are 2 separate problems. All right, so let's see if we get the same thing. The first one, we solve for y. We have negative 2y equals negative x plus 4. Divide everything by negative 2. We get y equals 1/2 x minus 2. And the other one, all we need to do is divide by 2. So we get y equals 1/2 x. So when you type these in the calculator, you might be able to tell visually, but maybe not. 1/2x minus 2. 1/2x. Let's make sure. Good. Okay, and when you look at these two on the graph, you'll see a line like this and a line like this. And lines technically could be close but cross at some point in the future, but that's what the calculator can tell you when you go through the process. These look like parallel lines, which would mean that there is no place they intersect. If that's the case, when you type this in your calculator, when you hit second trace to get into that calculate menu, then you hit intersect and then enter, 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 it'll say error. Something is going wrong. And that's because there's no place that they intersect. If that happens, there is no solution. Okay, for the second problem, solve for y. We have 4y equals negative 2x plus 10. Divide by 4. You can separate, or like we did in the previous, or you can keep them together like this. It doesn't matter when you're typing them in. You just have to put parentheses when you type. And the second one, we subtract 2y, so x minus, we subtract x, 2y equals negative x plus 5. So go ahead and type these two in the calculator. When you look at their picture, I want to show you exactly what it looks like. Negative 2x plus 10, all divided by 4, and negative x plus 5 divided by 2. So in the calculator, we see a line like this, and then we don't see anything else. And there's more than one thing that could be happening here. It could be that the second line, your calculator only shows you a small window. So one line is right here. It could be the other one exists somewhere that you're not seeing. Or it could be that they're the same line. So if you go through the process of finding the intersection, it'll give you one ordered pair, but there's a bunch of ordered pairs that work. So in this case, that dotted line shows that they're the same line. If you see something like this, go ahead and look at the equations. You can see a relationship here. If I had simplified in this first one, kind of took that 2 out, 2 and 4 would simplify, and I would get ultimately the same equation. So this one has infinitely many solutions, but this isn't how you present the answer. It has infinitely many solutions, but it isn't the case that every solution works. It's every solution on this line. I couldn't say that ordered pair works. So this is how you present the solution. All solutions 2, and then you list one of the two equations. It doesn't matter which one, but this is how you'll give the answer. All solutions to this equation. So this basically says if an ordered pair works for this equation, then it works for the system of equations. System meaning more than one. All right, so that's a little bit with graphing. The next set of notes we'll look at is for the first objective, determining if an ordered pair is a solution to the equation. And for everything else, we'll be without the calculator. All right, so determine whether -1, 1 is a solution to the given equation. The only note for this type of work is that it must be true in both equations to be a solution. We don't necessarily know what these two lines look like. Maybe they look like this. And maybe this ordered pair, -1, 1, obviously doesn't work here, but maybe it works for one of them, but not the other. We are looking for the point that they intersect. So we need to decide if it works for both of them. So pretty simply, you just plug this in, see if it works for both equations. All right, so we have x minus 2y equals 4. Let's test that one first. We have -1 for x minus 2 times 1 for y equals 4. We get -1 minus 2 equals 4, 3 equals 4. That does not work, which means this is not a solution. Not a solution. If it doesn't work for one of them, then it definitely can't work for both. Now, if it worked for the first one, but not for the second one, then we would also say not a solution. You have to check both if the first one works. I think there should be one more. Pretty simple. Yeah, go ahead and practice these. Pause the video, go through these two practice problems. You're plugging in each ordered pair, the first one, 1, -1, into the first two. You're deciding if that ordered pair is a solution to the system, and if -2, 3 is a solution to the second system of equations. All right, let's see what we get. So the first one, we plug in our x is 1, so -1 plus y is -1 equals 2. -1 plus -1, -2 equals 2 is not true. So this is not a solution. No need to check the second one if it doesn't work for the first, because it definitely can't work for both if it doesn't work for one. All right, the second one, we have 5 times -2 plus 3 times 3 equals -1. So we get -10 plus 9 equals -1, -1 equals -1. That's true. That's a true statement, so we can keep going. This number doesn't necessarily, it just has to be a true statement. It doesn't have to be -1 equals -1, 0 equals 0. it could turn out to be anything. If there's variables on each side, it's not going to be as simple as one of the pieces of the equation. It just needs to be a true statement. So it worked for one. Let's test the other. Our x is -2 minus y is 3 equals 1. -2 minus 3 gives us -5. -5 equals -1 is not a true statement. So is this yes or no? What do you think? The answer is no. If it doesn't work for one of them, then it can't work for both. So this would also be not a solution. Good. Okay, if it works for both, then pretty easily it is a solution. Then you've found either the one place they intersect or they're the same line. But if it's just asking if it's a solution, you don't really care what the scenario is. That's all you want to know, is it a solution or not? All right, so let's get into the real heart of this section, which is using the two main methods, substitution and elimination, to actually solve these problems. So here are our steps for substitution. I like to give you the word steps. You don't have to memorize these. This is just a guide to get you going on it so that hopefully you can go through the process without the steps. So the first step, again, we have two linear equations that were presented, is to solve an equation for one variable. So you pick which equation, you pick which variable. Then substitute it into the other equation. Once you've done that, there'll be one variable. You'll solve for that variable, and then you'll use that solution to solve for the other variable, and you'll have your final answer. All right, so let's go through using substitution. We have 2x plus 4y equals -6, and x equals 2y minus 5. So the first step is to solve one of the equations for one variable. If we chose the first equation, let's say we chose x, we'd have to subtract 4y, divide by 2. If we chose 4y, subtract 2x, divide by 4. There'd be some work involved in solving for a variable here. In the second equation, if we solve for x, it already is solved for x, so there'd be no work to do. If we solved for y, there'd be a little work to do. So it's always your choice, and it'll work no matter what you do. But if we were to solve for one of these other variables, we might have a fraction in the equation, which is not ideal when we're moving forward solving. So we're going to choose x in the second equation because the work is already done. Then the second step is to take what we have solved and plug it into the other equation. So if we know x is equal to 2y minus 5, we can take 2y minus 5 and plug it in to x in the other equation. So that would give us 2 times, instead of x, 2y minus 5. Continue the rest of the line, plus 4y equals -6. Then the next step says solve for that variable. So at this point, we have an equation with one variable. We can solve it. Distribute the 2, 4y minus 10, plus 4y equals -6. Combine like terms. Add 10. Am I missing something? No. Okay, good. 4 divided by 8. We get y equals 1/2. Simplified fraction. Not ideal to have a fraction as your answer, but that's possible. So if that happens, we deal with it. Okay, we have the y coordinate. So imagine of those scenarios, something would have went wrong if they were parallel. Something would have happened where we would have said there's no solution. Something would have happened, or maybe will happen in the next piece if they are the same, but we got a number. So that means there's one solution, find the corresponding x value. So plug this back in and solve for x. Now it doesn't matter where you plug it back in. You could pick this one, you could pick this one, anywhere that has an x. None of these have an x, so we wouldn't want to use those. The easiest is going to be this one because it's already solved for x. But plug it in anywhere. The x solution will work for either equation, so it doesn't matter. All right, so we know that y is 1/2. 2 times 1/2 is 1. 1 minus 5, -4. You have found the two coordinates, so your final answer is the ordered pair negative 4, 1/2, which is where they intersect. So let me write down using those steps. In step 1, we chose x in the second equation because it was already solved for there. This is step 1. In step 2, we substituted in. In step 3, we solved for y. So this was 2. This is 3. And in step 4, we solved for x. First, identify which you're going to solve for. Get that to say one of the two variables equals everything else. Make your substitution. Solve for whichever variable is left. Use that to find the other piece of the solution. All right. Let's do one more together with substitution. So we have y minus 7 equals 4x, and 2x plus y equals 4. Okay, so step 1, we have to choose which do we want to solve for. Well, it's not like the last problem where one of them already is solved for, so we have to make a decision. We could choose x or y in the first, x or y in the second. If we go with the first equation, I would suggest not solving for x, because if we solve for x, we divide both sides by 4, and now we have a fraction. If we solve for y, all we have to do is add 7 to both sides. In the second equation, if we chose x, we would subtract and divide, which would leave us with a fraction. If we solved for y, all we would do is subtract. So it's really your choice. The first or the second, solving for y seems to be the easier one. So in this case, we're going to choose y. And like I said, it really doesn't matter first or second. I'll just go with the first. Okay, so we have y minus 7 equals 4x. If I solve for y, I'm adding 7 to each side. Okay, step 2 is to then substitute that into the other equation. So here's what we got y to be. Now we're going to plug that into the second equation. So instead of y in the second equation, we write 4x plus 7. So we have 2x plus, not y, 4x plus 7. That's what we know y to be equal to, equals 4. Okay, continue on from here. So solve this. We have 6x plus 7 equals 4. Subtract 7. Let's bring this up here. We get 6x equals negative 3, divide by 6. X equals negative 1/2. There's one piece of our equation. Oh, that was step 2 and step 3. This is step 3. Step 2 is the substitution. Step 3 is actually solving. And then step 4 is finding the corresponding x or y value. We found x, so we want y. Your choice. You can plug it in here. You can plug it in here. You can plug it in here. Whatever you want to do, as long as you find a way to get that y coordinate. I'll go with this one since it's already solved for y. So 4 times negative 1/2 plus 7, negative 2 plus 7, 5. So we have the x and the y coordinate. Our final answer is the ordered pair. Negative 1/2, 5. Okay, let's look at elimination. We'll practice them all at once. Elimination is just another way of doing it. So you saw when we looked at the last problem, let's just look again, why we discussed it would be difficult if we solved for x or y, in either of the two equations. There'd be some sort of fraction still involved. So this method is a way to avoid having to deal with fractions if you can't get away from it. So you choose which variable to eliminate, then use algebra to get that variable to have the same coefficient with opposite signs, same coefficient, opposite signs. Then vertically add the two equations together. And then the last two steps are the same. Solve for that variable and use it to solve for the other variable. Sounds kind of cryptic, but I can't say x or y because it'll vary from problem to problem. All right, so let's see what that looks like in action. All right, step one is choose a variable to eliminate. And we're looking forward knowing that we're going to vertically add these two equations together, and I want one of them to cancel out. So if I choose x, I have a positive 1 and a negative 1. The second step is to get the variable to have the same coefficient with opposite signs. So a positive 1 and a negative 1. In this case, we're already here. If I chose y, I have negative 5 and 1. I'd have a little bit of work to do. So trust me, it's not as complicated as it seems. We are going to choose x. This will be step 1. We're choosing x. Step 2. And sometimes it's an easy choice. Sometimes you just have to pick one. Sometimes your decision won't make a difference. You just got to pick one and go with it. Step 2 is to then get the coefficients to be the same but opposite signs. So current coefficients are 1 and negative 1. They already are the same with opposite signs. So no work to be done in step 2. Step 3 is to vertically add the equations together. One important note is that the equal signs have to line up. So we're vertically adding. So we have x minus x, gone. We have negative 5y plus y, negative 4y. Negative 12 plus 4 gives us negative 8. We're allowed to do this if we know negative x plus y is equal to 4. If those are balanced, I can add that same balance to this equation. If I'm adding 4 pounds and 4 pounds to both sides, I'm not changing anything. I'm just manipulating it so I can simplify for myself. Okay, then the rest is pretty easy. In elimination, you do a lot of the work up front. The rest, simple. So step 4 is to solve. We have negative 4y equals negative 8. Divide by negative 4, y equals 2. And step 5 is to find the corresponding, in this case, x value. So plug that back in. Plug that 2 into any equation you want to. I'll go with that second equation. Y is 2. I get negative x equals 2 or x equals negative 2. So the final answer is the ordered pair negative 2, 2. This problem would work out exactly the same way if I chose y, went through the whole problem. If I took this y value and plugged it into the first equation, I'm still going to get that same x because no matter what, I'm referring to the one place that those two lines intersect. And so far, we've pretty much seen problems that have one intersection. All right, let's do another elimination. Okay, so we have 3x minus 2y equals 10 and 4x minus 3y equals 15. So step 1, choose a variable to eliminate. We have 3 and 4 as coefficients, negative 2 and 3 as coefficients. It's not going to make a difference. We're going to have to do the same amount of work either way. So let's go with y in this case. I'll choose y. Okay, step 2, get the coefficients to be the same with opposite signs. So currently, I have negative 2 and negative 3. I'm going to use algebra to get them to be the same. So what number can I get them to be? By multiplying the equations by stuff, what could I get them to be? The smallest thing would be 6, could go 12, could go 18, you could go higher. The smallest thing that I could get these two to have in common by simply multiplying each equation by a number would be 6. So we want the coefficients to be the same, but opposite signs. So I want 6 and negative 6. It doesn't matter which one's positive, negative, just pick. So let's go with the first one being positive. So step 3 is where we actually make this change. So what am I going to multiply the first equation by to get this coefficient to be a positive 6? Currently it's negative 2. So I multiply by negative 3. So this is step 3 happening. So distribute that. We get negative 9x plus 6y equals negative 30. Okay. The second equation, I want to have a coefficient of negative 6. It already has negative 3, so I only need to multiply in a 2. This gives me 8x minus 6y equals 30. Okay, then vertically add them. Oh, this is still step 2, my mistake. Step 3 is where we vertically add. So the equal signs line up. I'm vertically adding everything on the left and everything on the right. So on the left-hand side, I have negative 9x plus 8x gives me negative 1x. 6y minus 6y gone, equals is still there. Negative 30 plus 30 is 0. This is what I'm solving. This is step 4. How do you solve this? How do you get x by itself? Divide by negative 1, just like usual. And 0 divided by negative 1 gives us 0. That's okay. This is not one of those special cases. 0 is an okay solution here. So we found the x value. Now we need the corresponding y value. So take that 0, plug it back in, and see what you get for y. Any equation along the way, these two, it doesn't matter. I'll just go with this first one. 3 times 0 minus 2y equals 10. Looks like I get negative 5. So the ordered pair, the final answer, 0, negative 5. You can see why elimination is helpful as a method compared to substitution, because no matter what we try to do with substitution here, we would have a fraction involved, and that would make it complicated. So some problems it will specifically ask you to use substitution. Some it will say elimination. It's possible a couple will say by graphing. And some problems it'll just say solve, and then whatever seems the most, I don't know, easiest for you is what you can do. It'll be up to you. But you will need to know how to do both methods when it comes to a test. Okay, I think we're at practice. Good. Okay, so go ahead and practice these problems. The graphing we really only touch on a little bit, so I don't even want you to use that as a backup here. I want you to use the given method, substitution, elimination. First one, specifically substitution, elimination on the second, and then the third and fourth, you pick whatever seems most appropriate. Pause the video and we'll go through them together in just a quick moment. Okay, so let's see what we can do on each of these. The first one, we're using substitution. So choose which variable you want to solve for. In this case, the easiest one to solve for is definitely going to be this y, because there's dividing, but it's dividing by just a negative. So we would first subtract 5x. We have negative y equals negative 5x plus 21. Divide by a negative, which gives us 5x minus 21. Then we're going to take that and substitute it into the other equation. So we have 2x plus 7 times 5x minus 21 equals negative 36. So we have 2x plus 35x minus 147 equals negative 36. Combine here, 37x minus 147 equals negative 36. Add that 147, and we get 111. Divide by 37, we get x equals 3. Take that 3, plug it back into any equation along the way. I'll go with this one. I'm trying to fit it all on one page. We get 15 minus 21, which is 6. So our y value is 6. The ordered pair, 3, 6, using substitution. Okay, elimination. You choose if you want to use x, eliminate x or y. I'm gonna go with y. And the reason I'm choosing y is that one of them is already positive and one is already negative. I already have opposite signs. The problem will absolutely still work if you choose x, but I'm gonna choose y. All right, so the coefficients I want are going to be 2 and negative 2. So all I have to do is modify the first one, multiply everything by 2. That gives 10x plus 2y equals 18. The second equation already has the coefficient I want. Then vertically add. So we have 11x equals, looks like 36. Oh, I forgot to multiply it. Whoops. 18 times 2, 36. There we go. Plus 8 gives us 44. And then solve, divide by 11, x equals 4, which means we have a solution here. So plug it back in, find the corresponding y. I'll go with this one. 5 times 4 plus y equals 18. 20 plus y equals 18. Y equals negative 2. So the ordered pair, 4, negative 2. There's your solution for the second one. You should get that no matter which way you went through the problem. All right, the third one, it's your choice. I would suggest elimination for this one. If you go with substitution, you'll have to solve for x or y, and they all have a number coefficient that when divided would keep a fraction in the problem. So I'm going to go with elimination. No matter what you pick would be fine. And I'm going to choose x. So let's say I want to eliminate x. I want the coefficients to be the same but opposite signs. So I'll go with 10 and negative 10, or negative 10 and 10, since the first is already negative. So the only change I have to make is to this first equation. It needs to get multiplied by 2, which gives me negative 10x minus 6y equals 18. The second equation already has the coefficient I want. Then vertically add, negative 10x plus 10x gone, negative 6y plus 6y gone, so I have nothing, equals, this is a negative, 18 minus 18, gone. I have 0 equals 0. This is possible. What do you think it means? On every previous problem, pretty much, we've seen an actual number solution, which means there's only one spot that the two intersect. This is one of those other cases. It's either that they are parallel or that they are the same line. What do you think? Which one do you think it is? If we're getting a true statement, which do you think it is? True statement tells us that there are infinitely many solutions. They are the same line. So first I'll write that, infinitely many solutions. This is what happens algebraically in either method if you have the same line. There are infinitely many solutions, and you can write this all solutions to choose an equation, negative 5x minus 3y equals 9. This is how you could present. And then the other one, 12x plus 2y equals 10, and 6x plus y equals 3. For this one, I'm going to choose substitution. You could easily pick elimination here as well, but I see an easy way to solve for y, so I'm going to go with that. So this equation will become y equals negative 6x plus 3. Then I substitute that in for y in the other equation. I have 12x plus 2 times negative 6x plus 3 equals 10. 12x minus 12x plus 6 equals 10. I get 6 equals 10. Another special thing happens. I get to a point where the variables have canceled out and I'm left with a statement. The previous one, we got a true statement, which meant they were the same line. There were infinitely many solutions. This time I got a false statement. And this is our third scenario. They are parallel lines, and so what kind of solutions do we have? We have no solutions. So, no solution. Another way to list this. So, algebraically, this is what it would look like. This is what it will look like if these special cases happen. If not, you will come up with an x, you find the corresponding y. So this video primarily looked at substitution and elimination. We saw a little bit of using the calculator and then a little bit of verifying a solution. But the majority of our work, substitution and elimination. Make sure you are comfortable doing both methods. The computer system for your homework won't know which one you're using, but you will be asked to use each one individually on a test. I will see you soon for another video.